Secured shell. Secured shell, that's the name given to a protected, safe, secured telnet. Hey, this is not ordinary telnet. This is telnet but in a secured way. Then what is the problem with the telnet? It's not secured. Plain and simple. Telnet will help you to see the remote device down on your PC. But over the network, when that remote device is shown to you, it's basically packets coming to you and displaying my computer in your computer. It's not literally my Dell computer sitting inside your computer. It's my desktop copy. It's my VGA card. It's my graphics card, which used to show me in my screen, now shows you in your screen, which means from the motherboard of my laptop, instead of coming to my desktop, instead of coming to my screen, it goes through the wire and shows in your screen. That's telnet. When you see my screen, it means you have telnetted. Have we done telnet?
No.
We have not done telnet before?
Oh yes, that is what it is.
We did or we didn't?
In the network we did, so yes.
We did, yes. We did telnet. We logged into our Cisco device. You remember? We used to telnet to Cisco routers. And we were configuring the remote device in the local router. From the local router, we were configuring the remote router. That's telnet. Now this telnet is nothing but sharing of your screen with someone. So in Windows we call it as what? A remote desktop. There is also an application, right? TeamView. Now TeamView and all gone. We have this Google Meet, Cisco WebEx, Zoom. There are many more. Now, to share your screen in a secured manner, we take the support of this service called SSH, Secured Shell. Can anyone recall and tell me the port number of telnet? What is the port number of telnet?
23, sir.
Yeah. SSH is 22, just one number less. TCP 22. SSH is TCP 22. Now, if I'll go to this router, me here, and somewhere in the internet, there is one router with the address, let's say 80.001 and minus 20.001. Now when I go here and say SSH to that address 80,001, what really happens is packet with the source address 20,001, destination address 80,001, and the source port number, this is layer 3, and layer 4 source port number, that's going to be a random port number, and the destination port number is going to be 22. So when a packet is routed by this all internet routers to this address, it will go to this address, and then this device will read the port number, and it understands that I'm expecting SSH service. This remote device understands that it needs to reveal itself in a safe way. How this SSH can provide a secured remote login? Through encryption. Before that, I remember I showed you while telnetting, even the passwords are revealed in the Wireshark, didn't I?
No, sir.
I did?
Right.
Okay, I'm going to show. So we got reachability between R1 to R4. See, I'm able to ping R1 from R1's 1.1.1.1 to R4 4.4.4.4. I don't know whether I taught you this. You can create a logical interface called loopback interface. If you notice here, I have a loopback interface. That's not a physical interface. I'm pinging from this loopback interface by putting the source command. I'm saying ping from this address, not from the exit interface address. Hey, you can also ping without that. You see, you can also ping without that. When you ping without that, it will take 10.12.01 as the source and 4.4.4.4 as the destination. But when you put this what? This, the source becomes the 1.1.1.1 address and the destination is 4.4.4.4. Now, what is next? Next is we are going to enable telnet on router 4 to see how vulnerable is telnet. Line VTY 04 transport input telnet login local username Cisco, password Cisco, username sys, password sys. Okay, now I'm going to do the telnet from router 1, but before that I'm going to capture every packet that goes out. Start capturing. See, you're not using this tool. I know that you're using packet tracer, but to show this packet level I need this GNS3 tool, so I'm using this GNS3. Don't worry, you just learn the concept here. I'm going to telnet from router 1. I'm saying telnet 4.4.4.4. You see, it's asking the username. Now let me go here. I can show you the telnet packets. Look at this, the telnet packets. Let me do one thing, filter telnet only. So it shows only the telnet packets. Packet was going from where? From 10.12.01, it goes to 4444. And now there is an echo. There is a response. What is the response? This is the response. Trying, user access, verification. These are all coming as a response from where? From R4. R4 is asking question. If I need to allow you, provide me the username. Now, can we see those things? Why not? I can show you. Follow TCP stream. Look at this. User access verification, username. You know, whatever I was seeing there on the router, I can also see here sitting in somewhere in the middle on the roadside between R1 and R2. There is a big internet. Someone can sniff the packet and see what has been shared between you both. Very dangerous, no? Not only that, you see, I'm going to now type again telnet, username Cisco, password is CISCO. Now I'm inside R4. This is what telnet means. R1 is saying R4. Right now I'm in, though I'm in R1, you can see R1 on the top, but I'm right now seeing the screen of R4. Now go back again and ask this guy, can you show me the stream again? Stream again for me. Look at this. Hey, where are you? Show me. Stream, stream. I open again, I open again. Open again. Hey, what happened? Why are you not showing the passwords? Trying again. Telnet. Okay, now I'm going to show you the stream. There you will find username and password. Up. Let me do one thing. I'll do it again. Stop the capture and exit from here, and I'm going to start the capture again. என்னை நீதிமானாய் மாற்றினது உந்தன் கிருபை. Okay, Cisco. Now I would like to show you again. You see that? Username, you see? C-I. Why it is repeating 2 times? Because when I type C, it goes to router 4 and comes back to my screen to reflect. But when I type password, passwords are not reflected, right? See? When I type password, passwords are not reflected. But when I type C, I'm actually typing on R4. So from R1 it goes to R4 and comes back to R4. That's why C is twice, I is twice, S is twice. This is the main story. Password is revealed. Very dangerous. Telnet is dangerous. Vulnerable. That's the reason why we don't use telnet in a unsafe environment. So we are moving on to SSH. After I enable SSH, I'll do the similar sniffing. I'll show you. You cannot see any password there. Instead, you will see some encryption. Okay, so we understand why we need SSH now. Now, how to enable SSH is what I'm going to show you next. Go to R4. First, let's go to line VTY04, where we were saying transport input telnet. We said this. I'm going to say now transport input SSH. If you want both, you can say SSH and telnet. You enable both. Alright, and the same username, same password, so I'm not going to disturb anything. Okay, this is the first step, but this is not enough. You also need to do something more. What is that? We need to generate key. You know, key, lock and key. We need to create keys, and we need to create two keys. One is called public key, the other one is called private key. So this public key will be the key that I will give to everyone. Whoever wants to talk to me, talk using this public key. I'll give to everyone, whomever I like. And that person who received my public key, whenever he talks, he wants to talk to me, he will use my public key, which I gave him, encrypt whatever he wants to say. He will encrypt it with my public key and he will send it to me, which can be only opened by the private key which I got. No one else have got my private key, so no one else can open the packet. That's the secret. That's how SSH works. I want to repeat the story again. It's very interesting, you know. Two keys I generate. Who is I here? R4. R4 generates two keys. One is private key. Why it is private key? It will not be shared to anyone. It won't be given to anyone. It will stay with R4 itself. That key will not be given to anyone. The other key is public key. The key name itself is public. That will be given to everyone. Whoever wants, they can use. Now R1 got the public key of R4. What R1 will do, it will take my public key, R4's public key, encrypt whatever it wants to say, that data, that information, whatever it wants to communicate to R4, it will encrypt with the key which R4 gave. R4's public key. It will encrypt with it and it will send it to R4. In the middle, if anyone is capturing the packet, they cannot read it. Why? It's encrypted. To decrypt it, they need the private key. Who has got the private key? Only R4 has got the private key. Even R1 don't have the private key. R1 itself cannot decrypt it. Once R1 encrypts and sends, R1 itself cannot decrypt again, because it has been encrypted by using R4's public key. Only R4's private key can open it. That is what safety here. No other device in the middle can open, because they don't have the other key which will open the packet. If you want me to tell with one simple example, today's gospel. how churches preach gospel. They take only 1 drop of honey and mix with 1,000 liters of water and say this is honey. And believers also believe that, I got honey. I got honey. Since they have never tasted the real honey, for them that 1 drop of honey with 100 liters of water tastes much. They think that is the real honey. Only the pastor knows that it is only 1 drop of honey. Because he only mixed that 100 liters of water to it. Very sad. Another example. This will be like movie example. Someone wants to smuggle gold. If they bring us a gold, they will find it. Who will find it? The customs office. So what they do? They mix with sand. 10 kg of sand, 100 gram of gold. Mix. Anyone who see will see only sand, because sand is of 10 kilograms. This is only 100 gram. Very hard to find out that there is a gold hidden inside. Only the one who mixed it knows that there is a gold. No one else can identify the gold in it. Likewise. R4 is sending its public key to R1. R1 is encrypting with the public key. Only R4 knows that it is encrypted with my public key. I'll use my private key to open it. No one else can open it. Right? So, let's see how to do that. Creation of private key and public key. This is the first step. You need to give a domain name. IP domain name. Let's name it as jesusiscomingsoon.com. Next. Crypto key generate crypto key. It's there. Generate RSA. Enter. You see, it immediately taken the host name of the router along with the domain name jesusiscomingsoon.com. With this and with the date and time on the router and with this 512, which is equal to, like what I was telling in the example, 100 liters of water for 1 drop of honey, 10 kilogram of sand. This is the 10 kilogram of sand what I have highlighted. If you want more kilogram, more stronger, you can say, or you can also say 2048. More stronger it will be. Alright, so more bigger number you type, more bits will be used to mix that gold. Gold is the data that R1 is going to share with R4, and this 2048 is the sand. See, it is generating the key. Key is generated. See, SSH got enabled. SSH version 2 has been enabled. Now, if you want to see the key, I can show you the key also. Show crypto RSA, show crypto key, my pub key, RSA. This is the key. See, key pair generated today, time, date, and all. And this is the key server, r4jesuscomingsoon.com server, RSA key, and you can see the key. This is only a public key. It won't show you the private key. This is the sand which I was talking about. Alright. Now SSH is enabled on R4. Go to R1 and let's do SSH now. SSH 4.4.4.4. SSH, see, there is a syntax you need to follow. SSH -L, that's not one, okay? Login -L, and then username is Cisco, and the address is 4.4.4.4. Okay, this is the syntax, okay? Now it is asking me the password. Password is also Cisco. Look at this, I'm able to see R4. But this is very safe. But what I fail to do is I fail to sniff the packet. So let us go out. And now I'll go and sniff the packet between R1 and R2. And here we go. Do the SSH again. You see, background SSH version 2 is running. Now CASEO. Right. We are logged in. Now I'm going to sniff one of the packet and show you. See? Full of sand. 100 liters of water. Can you guess the password here? No, you can't. This is not password. This is Cisco router, name router. This is just Cisco router. Because we are logging into Cisco, no? Unfortunately, we use that same word as a password, but this is where password somewhere hidden. The username and password, everything is hidden somewhere here. You see, no one can come with the password. See how many algorithms are used. AES, triple S, Diffie-Hellman, hashing algorithm, MD5, SHA. So that's the sand, that's the water. So that no one will know the real thing. Okay. So I hope you understood SSH, the need of SSH and how to configure SSH. Is there any question? You may ask now. I know you have to see this video once or twice to get the whole configuration part. Story is well understood, but the configuration is a little bit difficult because there are a lot of things I did, but not much. Believe me, it's not too much. What I did is I enabled SSH underline VDY. Optionally, you can enable both. And then I created a domain name. And then the reason why we need to give domain name is to generate the key. The host name, the domain name, and the time, date and time are important. And then what I did is I just put this command, crypto key generate RSA. And then if you want to leave the size default, good. If you want to make it more stronger encryption, then put this number. Anything 512 is also okay, but for in the real world we don't use 512. 512 is weaker, so we go with 1024 or 2048, something like that. Right, 2048 will enable SSH version 2. Anything less than this number will be SSH version 1. Alright. Any question?
சார் அந்த ஐபி டொமைன் கிரியேட் பண்ணுறீங்களா சார் அது அதுவும் இந்த டிவைஸோட நேமையும் ஹோஸ்ட் நேம் ஹோஸ்ட் நேம் மேட்ச் பண்ணி அது கிரியேட் பண்ணுமா சார் அது
Yes. See, you can see it here, even right here. You can see when I put show crypto key in my pub key, show me my public key. This is the meaning of it. Show me my pub key. It says that the key name is r4jesuscomingsoon.com. What is Jesus Coming Soon? It's the domain name which I gave to the router. Do you remember? Yeah? Do you remember that?
Okay.
I gave the name as what? See the domain name. What did I give?
Yes.
So it takes the
Jesus coming soon.
Thank you for acknowledging that. See, it has taken the domain name. It has also taken the host name to generate the key. Yeah? Yes. So domain name is important. Any other question? All right. What about others?